Okay, so let's do this problem really quickly. We have the question of whether or not there's enough medication in this container of Keflex to provide this kid 150 milligrams per day for 10 days. So the very first thing we got to know is how much the kiddo is going to need in 10 days. $150 milligrams a day, he needs that for 10 days. That's 1,500 milligrams over that 10-day period. Right? So that's how much I know he's going to need. The question then is, does this container contain 1,500 milligrams? Well, I go to the label, and I see that right here it says there's 1.5 grams of cephalexin dry powder. It's even pleasantly flavored in the container. And you know that 1.5 grams is the same as 1,500 milligrams. So there is enough medication in this container. At this point, we have no concern about what the concentration is, how much volume it's reconstituted with, anything like that. We just want to know if this container has enough medicine, enough mass of medicine to provide this kid with 150 milligrams per day for 10 days. The answer is a resounding yes, it does. Let's look at some other ways to calculate this. Okay, oftentimes when we're doing these equations, our eyes are drawn to whatever is written most largely on the label or in a different color on the label. And so this 125 milligrams per 5 mil is written pretty big. So we'll start with there. So we have 125 milligrams per 5 milliliters. Now remember that anytime we divide a number by itself, so if we divide 2 by 2, or 4 by 4, or 18 by 18, all these fractions equal 1, right? 2 divided by 2 is 1. 4 divided by 4 is 1. 18 divided by 18 is 1. So don't forget that, because I want to get rid of this 5. I want it to be 1. So I am going to divide this fraction by 1, but I'm going to do it by dividing it by 5 over 5 because I want to get rid of this 5 right here. Right? Because I like this number to be 1 most of the time. It makes my math much easier. I can do it in my head. I don't need a calculator. If I am using a calculator, it makes it easy for me to check my math afterwards because I can look at it and see if it makes sense. Okay, so in this bottle, because there's 125 milligrams per 5 mils, each milliliter contains 25 milligrams. I know that the question is whether or not if we give 150 milligrams per day, there's enough medicine in the bottle for this kid to get enough for 10 days. So I have 25 milligrams per mil. What I want is 150 milligrams per day. So how do I get there? Okay, well, to go from here to here, I divide by 6, right? Yeah. I mean, those are the two that I know. I know 25 and 150. Remember the ratio thing. So I'm going to multiply by 1, 6 over 6. And I've chosen 6 over 6, which is 1, because to get from 150 to 25, I divide by 6, or to get from 25 to 150, I multiply by 6. So 25 times 6 is 150. 1 times 6 equals 6 milliliters. So every 6 milliliters of this medicine contains 150 milligrams, or every time I give 150 milligrams of this medicine, it's going to take 6 milliliters. So then if I multiply that by 10, for my 10 days, remember I'm going to get 1,500 milligrams, because we did that on the previous one, and 60 milliliters. So in order for this kid to have a 10-day supply of medication, if it is reconstituted properly, then he's got to have a total volume of 60 milliliters. And does he? Well, sure he does. Right there. 60 milliliters of medication in this, 60 milliliters of volume, 60 milliliters of solution in this bottle. So either way we work it, we see that he's got 10 days worth. And in fact, when we do it different ways, we can check our work and know whether or not we're moving in the right direction. Hope this was helpful.